Inorganic Chemistry, Round 1, Part 4. Why is the coupling constant measured in Hertz and is not recorded as a chemical shift difference? The coupling constant is always the same when expressed in Hertz. If expressed in parts per million, the coupling constant depends on the field strength of the magnet being used. Coupling constants are always expressed in Hertz for this reason. What are the features that distinguish X-ray quality single crystals, a crystalline solid, and an amorphous solid? Crystalline solids have well-defined edges and faces, diffract X-rays, and tend to have sharp melting points. In contrast, amorphous solids have irregular or curved surfaces, do not give well-resolved X-ray diffraction patterns, and melt over a wide range of temperatures. A polyatomic species contains 3 or more atoms. Hybrid orbitals are generated by mixing the characters of atomic orbitals. A set of hybrid orbitals provide a bonding picture for a molecule in terms of localized sigma bonds. sp. Linear. sp2. Trigonal planar. sp3. Tetrahedral. sp3d. dz2. Trigonal pyramidal. sp3d. dx2 minus y2 square-based pyramidal. sp3d2 octahedral, sp2d square planar. What is meant by a ligand group orbital? In molecular symmetry terms, the 6 lone pair orbitals from the ligands, 1 from each ligand, form 6 symmetry-adapted linear combinations, SALCS, of orbitals, also sometimes called ligand group orbitals, LGOs. Ionic solids are typically insulators. Manganese stands out among the D-block metals as having an unusual structure. The atoms are arranged in a complex cubic lattice such that there are 4 environments with coordination numbers of 12, 13, or 16. Low carbon steel contains between 0.03 and 0.25% carbon and is used for steel sheeting, e.g. in the motor vehicle industry and in manufacturing of steel containers. The major raw materials for the commercial production of iron are hematite, Fe2O3, magnetite, Fe3O4, and siderite, FeCO3. Medium carbon steel contains 0.25 to 0.7% carbon and is suited for uses such as bolts, screws, machine parts, connecting rods, and rails. The strongest of the carbon steels, high carbon steel, contains 0.8 to 1.5% carbon and finds applications in cutting and drilling tools. The corrosion of carbon steels is a disadvantage of the material, but coatings can be applied to inhibit such action. Galvanized steel possesses a zinc coating. Zinc has a low mechanical strength but a high resistance to corrosion, and combined with the high mechanical strength of steel, galvanized steel meets the demands of many industrial applications. If the zinc coating is scratched revealing the iron beneath, it is zinc that it oxidizes in preference to the iron. Stainless steel, so called because they do not become stained with rust, are examples of alloy steels, i.e. ones that contain a D-block metal in addition to carbon. Stainless steels have a significant content of the alloy metal and are of high commercial value because of their resistance to corrosion. All contain at least 10.5% by mass of chromium, the minimum that renders the steel corrosion resistant under normal aqueous conditions, i.e. in the absence of acid, alkali, or pollutants such as chloride ions. The resistance to corrosion arises from the formation of a thin layer of Cr2O3, right around 13 nanometers thick, over the surface of the steel. The oxide layer passivates the steel and is self-repairing, i.e. if some of the oxide coating is scratched off, further oxidation of the chromium in the steel necessarily repairs the wound. There are 4 main classes of stainless steel: austenitic, ferritic austenitic, duplex, and martensitic, and within these a variety of different grades. The electrical conductivity of a metal decreases with temperature. That of a semiconductor increases with temperature. A band is a group of MOs, the energy difference between which are so small that the system behaves as if a continuous, non-quantized variation of energy within the band is possible. Give two examples of metals that have a BCC structure at 298 degrees Kelvin. Each atom touches 4 atoms in the layer above it and 4 atoms in the layer below it. Atoms in BCC arrangements are much more efficiently packed than in a simple cubic structure, occupying about 68% of the total volume. Isomorphous metals with a BCC structure include potassium, barium, chromium, molybdenum, tungsten, and iron at room temperature.